All right. So we put in the data. Now we hit stat. We need to get the calc, which is right arrow. We're talking about one variable data, which is already highlighted. I have to hit enter, I don't know, a few times. Check to make sure this is in L1, nothing in frequency. And the number we're looking at, this is where it's a little goofy. On the calculator, we don't want the S sub x. We want the lowercase sigma. So we want the sigma of x, which is 1.41. If you notice, the mean is up there too if they're asking for the mean, which I guess we were. So the mean is 4. But we could have calculated that fairly easy without that. So if we look at the two answers, the first one was 2.61 and the second example was 1.41. We would say that these data points are closer to the mean than the first example. Or the phrase that IB likes to use, it has less variability. Variability, there we go. All right. Let's do a different example. Given that the sum of some expression is 140, and the sum of this binomial squared is 80, and they'll make a statement. It's a little wordy, but I don't want to abbreviate. This is how it was worded on the IB test. The mean of the population, x sub 1, sorry, it's sloppy, x sub 2, x sub 3, x sub 20 is m. So they're saying the mean is m. So instead of writing x with a line above it, they're just using m. All right. Two questions. I'll write them both down. Find m, find the standard deviation. This is more a question of vocabulary than anything, because there isn't much work to do here. All right, so finding m would be like finding the mean. So we just got to interpret which one of these sigmas are helping us find our answer. This one gives us the sum of all the data points, which is 140, and there are 20 numbers. So we're just going to use that one. 140 divided by 20 is 7, so the average is 7. So even though you will not have to write this out in problems, you do need to interpret this. So the sum of the data, 140, there are 20 data points, so we divide them to find the average. Where the standard deviation is using this. Remember, this is how far on average, or definition of standard deviation is how far on average each point is from the mean once you square it and divide it. Square root it and then divide it. Let me say that again. You square it, square root it. Let's try it one more time. how far each data point is from the mean squared divided by how many data points there are, and then you square root it. There we go. All right, so the square of all the differences, the sum of all the differences is 80. So we want to take that number and we want to divide it by how many data points there are, 20. So let me say that again. This is the sum of all the differences squared of the 20 data points. Now we're going to divide it by how many data points there are, which are 20. And then to find the standard deviation, we square root that. Well, 80 divided by 20 is 4, and the square root of 4 is 2. So the standard deviation is 2. And then the last section, I said we were going to spend 2 days on this. 20F, 2, and 3. Sampling from a population. All right, this first question directly from IB test. Again, it's more of a vocabulary. It's kind of wordy, but I don't want to take stuff out. There's not much to it, but because there's not much to it, it's hard for some people to do. Random sample of 48 sheep taken from over 2,000 sheep. The sample mean was 48.6 kilograms with a variance. Here's the only question that deals with variance. 17.5 kilograms squared. So again, we don't use variance too much because we don't refer to weight as being kilograms squared. So that's why we use standard deviation a lot more. All right, 2 questions. Again, these are both vocabulary questions. Find the standard deviation of the sample. So again, if they give you the variance, to calculate the standard deviation, you just take the square root of that. So the variance is 17.5 kilograms squared. So basically we square root them, and this will give us the standard deviation. So we take the square root of 17.5 and we round to 3 significant figures. 4.18. That's an approximate kilograms. And that's it. The second question is even more basic, but it can be pretty challenging because people think there's so much other stuff to do. Find an unbalanced estimate. Again, I took this right from an IB test, so I didn't make this question up. Find an unbiased estimate of the mean weight. Usually we think there's something we got to do, some formula, some work, or something like that. But when it comes to the unbiased estimate mean weight, it was already given. It's right there. So there's no work to do in this problem. 2-point problem, but some people actually have gotten it wrong. So there's the answer to that. Last example. Totally different problem. if different data has different frequencies, the problem gets a little bit harder. So in the last lesson, they all had a frequency of 1 or the same. But what happens if they don't have the same frequency? So if different data values have different frequencies, then it gets a little harder to do this. So for example, let's say you had 3 A's, 5 B's, and 2 C's. We want to find standard deviation. All right. We're not going to do this problem, but a different problem. All right, so they'll give you the first 2 columns. So the first 2 columns are given, so it has nothing to do with this. All right, so totally different example. All right. So again, the first 2 columns are given. 1, 2, 3, 4, 5. So all of this is given, and all of this is given. All right, so find the standard deviation given that. So here's our data points. Here's the frequency in which each of them occurs. So there are 1 1s, 2 2s, there are 4 3s, 2 4s, and 1 5. All right, so maybe I asked, let's see, 6, 8, 10 people how much money they have in their pocket, rounded to the nearest dollar. And everybody had money. All right, so we have to think, what do we do first? So similar to what we did actually when we were in school, we find the product. So we multiply these numbers. So our formula, maybe I should write the formula down first. Our formula, I'll put it down here, is almost the exact same thing. All right, let me just write down the formula if there was no frequency. Initial value 1, x minus, and that's what x sub I minus x, the mean of x squared, all divided by n. If there's a different frequency, that just goes right there. Frequency right in there. All right, so we find the product, and then we're kind of doing the same thing we did before. The sum of the difference, first we find the difference between each data point and the mean of x. We've got to find the mean. All right, so let's find the mean. This is where the product comes in. So I got a little ahead of myself. So to find the mean, we need to find the product and then the cube frequency. So we could just sum these up here. So there are 10 values. They all add up to 30. So the mean would be 30 divided by 10, which is 3. So we first had to do this. So I shouldn't have done this column until I started thinking about the mean. All right, so we first find the mean, which is 3. Now I can do this. So now we're just going to subtract each of these data points from 3. So 1 minus 3, 2 minus 3, 3 minus 3, 4 minus 3, and 5 minus 3. Then the formula tells us to square it. So we square -2, square -1, square 0, square 1, square 2. Formula again tells us to now multiply those differences squared times the frequency. So here's our new column. So we go way over here to F. Just making sure we can see here. F times this, 1 times 4, 2 times 1, 4 times 0, 2 times 1, and 1 times 4. Now the formula tells me to add those up. So that's 12. So I found the top number. Let's see if I can squeeze this in here. Top number is 12. The bottom number is n, which there are 10 of them. Oops. Sorry. Square root of 12 divided by 10. Round to 3 significant figures, 1.10. And there's our standard deviation. Now this all can be done on the computer or a calculator. So let's show it on the calculator. All right, let's see if I can do this right here. Let's put it over here again like last time. All right. So we go to Stat. Gotta clear out the data. All right, so we put in our data. Put in data. So remember, the first 2 columns were given. 1, enter, 2, enter, 3, enter, 4, enter, 5, enter. All right, so the first 2 columns were given. So I'm going to enter that into list 1 and the F into list 2. So now I'm entering the frequency. 1, enter, 2, enter, 4, enter, 2, enter, 1, enter. So all that was given. Now we hit Stat. Again, we need to go to Calc, so right arrow. Enter. But now we need to make sure frequency is in L2. So you probably have to put in L2 here. So L2 would be second number 2. And a couple more enters. And there's our 1.10. There's our mean. So it could have been done on the calculator. All right. Well, that's the week's worth of pre-calc lessons. Again, if you have any questions, send me an email. Hopefully this worked out well.